There are some other issues. For example, Colombia, for the interconnected system, has defined that 6.5% of its energy consumption is going to be renewable, and for non-interconnected zones is going to be 30%, and that goal is defined for 2020. Here it's important that what I miss sometimes in the renewable energy discussions at our countries is that we are always talking about environmental, we are always talking about diversification of the energy mix and all that stuff, but we forgot to talk about technology. And it is important to talk about technology when we're talking about renewable energy integration. And in that sense, we have also looked for local manufacturers of renewable energy, because if we want to promote the renewable energy in a complete whole sense, we also depend on local manufacturers. In that way, we can provide some strategic subsidy and some other mechanisms instead of buying electronic cheap technology. We have identified, of course, for Argentina and Brazil, different manufacturers. In Argentina, we have IMSA, which is already known, Renewable Patagonia, and some other companies. In Brazil, Texas, Gamesa, Enercon. IMSA is also present in Brazil. It's important to state that, for example, Texas is the largest wind turbine blades manufacturer right now. It's located in Sao Paulo. I had the opportunity to visit that plant. It's very impressive. In Chile, as Anna told us during the morning, there was an entrepreneur led by Fibrevent with Elson, more related with wind services and wind turbine blades for fabrication, manufacturing. And IMSA is also presented in Uruguay, but more related with wind technology services. There are also manufacturers for hydro turbine. We don't know specifically the names of them, but I know that they do really exist, because I have seen the plates of the machines in some cases, and they are located in Brazil, Peru, Argentina, and Chile. We are working with hydro turbines technology. Okay, and regarding infrastructure, the first question that we made ourselves was the renewable energy potentials. And this is just an example of the solar maps and the solar atlas that different countries have. This is Bolivia, Brazil, and this is the northern part of Chile with our great solar potential in the Atacama Desert. And we try to summarize. This is a comparative scheme of all the potential we have obtained so far. Those colored ones are basically more quantitative expectations of more qualitative expectations than quantitative ones. And it is easy to observe here that basically the more technologies that we are taking care is wind and hydro. We have specific numbers for hydro and specific numbers for wind, but no for the other technologies. And this is just a comparison, a quick comparison of how we have see the progression of the, for example, installed capacity of hydro. Here there's such a big noise because Brazil has a lot of installed capacity of hydro, so we changed that to percentage level. But anyways, Brazil has at the beginning of the 90s almost 90% of installed capacity composed by the hydro technology, and we also have all the other South American countries. We made that comparison for hydro and just presenting some examples how the evolution has been. This is energy generation, and also we did it for Germany, but in this case for the wind, but in this case Germany was the different technology, of course, because of the development, and we just began, as I told you, by the mid of the 2000s. So this is percentage comparison, and those are the first results that we have been obtained. And finally, what is related with renewable electrical energy communities, I want to talk to you about some background information. In that case, I want to talk to you about Guatacondo, which is an isolated rural town with 100 inhabitants, and it has at the beginning 10 hours of power supply per day. This small town is located in the desert of Chile, and it was that way. They had only 100 kV diesel engine and an abandoned solar PV panel, and we converted that small town to a hybrid microhydro, a hybrid microgrid development composed by 23 new kilowatts of solar power, 3 kilowatts wind turbine, and also a battery storage facility. And that's the way the Guatacondo's microgrid is composed. Here we have the generation units of the hybrid system, and over there we have all the loads, basically households, and the water pumping system of the town that was also included to the scope of the project. Now Guatacondo has, this is the way Guatacondo looks. Those are the PV installation over here, and that one is the town. And now they have electricity supply for the 24 hours per day, the whole days of the year. And basically the operation of the Guatacondo microgrid, it is as follows. For the first hours of the day, power supply is provided by the batteries. When the sun rises, we have a large solar energy production that even is greater than the demand, so the difference is used to charge the batteries. And later then, at the peak hour, we have the power is supplied by the diesel engine, and the difference of power of the diesel engine and the demand is also used to finally recharge the batteries. And that is the way the system is working now. And we have obtained savings of about 50% of diesel consumption, with the difference that they already have power supply 24 hours per day. And finally, electrical energy communities. With the support of the JELARE project, we have been working in the development of smart micro hydro plug and play unit, and this is the original technical solution that some specific locations have been using, with a lot of civil work, with a lot of technological barriers, because the unit is not smart enough to work in an isolated or reconnected way. So what we did is create a smart unit which is easy to install and completely automatic operation. You just have to power on the unit. The unit is working out at lab scale, and we expect to have this unit operative by the end of this year in a specific location. We are working with some channel irrigators right now in Chile, and they are going to provide us a specific location in Chile to put in operation that micro hydro unit. Some conclusions we have found so far about the comparative analysis. The power sector reforms is almost complete in what is regarding institutional coverage. By the mid of the 2000s, the renewable energy integration appeared in South America. There's not a clear signal for the adequate integration mechanisms, so we have to talk about technological development, chip buying. Are we going to subsidize? If we're going to subsidize, we have to be so careful, because it is important here, from my point of view, to subsidize local manufacturers instead of foreigner manufacturers. Brazil and Argentina may be identified as the technology nations at the South American level, and of course the European Union and Germany find in an anticipated way the need to introduce renewable energy, and of course leading technological development, which is a strategic decision. Other final conclusions: there are some specific niches associated to specific countries. Of course, Germany has a completely wind industry, completely developed. Brazil is working also in wind and hydro. Hydro, it also has the problem with the definition as a non-conventional source. It's a mature technology when we're talking about large dams and large front-of-the-river plants, but we believe there's a high niche for the South American countries with micro-hydro and mini-hydro technologies. With the main trouble that it's not easy to find data that make the differences between the large dams and the small generation units. Of course, this comparative analysis is also going to provide us the possibility to identify technology needs regarding renewable energy. And on the context of energy communities, microgrid applications to isolated communities, we have already an experience. We hope that that experience might be replicated to other South American countries. We are working for it, and we hope in the framework of the REGSA project we can do it. And finally, the development of energy sources for with application to energy communities, as we have been working with the micro-hydrogen. Thank you very much. It was a pleasure to talk to you all. And finally, this picture represents our latest work with the Watacondo community, which is a smart blackboard that is provided for the community in the community center, so they are able to monitor, control, and deal with the operation and maintenance of the microgrid, because we are also not only producing technology, but we are also taking care of the technology transfer and the sustainability of these energy projects in the long term. Thank you very much.